Hello everyone, myself P. Jithendar, Assistant Professor in Electrical and Electronics Engineering, MLR Institute of Technology. Right. So in today's video session, I am going to discuss about the losses in three-phase induction motor. Okay. So here, basically, the losses of the DC machine are same as the losses in the three-phase induction motor, but terms are changed here. So losses in DC machine, so we are having the copper losses, iron losses and mechanical losses. If it is a transformer, only two losses are there, that is copper losses and iron losses. And for the losses in three-phase induction motor, so we are having the two types of the losses here. Here we are having the two types of the losses. So first is variable losses and second one is constant losses. Okay, so here the constant losses are classified into two types. So first one is iron losses and second one is mechanical losses. So these are the losses in three-phase induction motor. So we'll discuss one by one. So here the first one, variable losses. So this variable losses, we can also call it as a copper losses. So here the copper losses are nothing but the power wasted in the form of I square R losses, and these type of losses are occurred at windings of the stator. So here these losses are occurred at windings of stator and rotor. We can call it as a copper losses or variable losses, right? So variable losses are nothing but the power wasted in the form of I square R losses, and these type of losses are occurred at windings of a stator and rotor, right? So here basically the variable losses, so variable losses we have to write the equation like this. So in terms of I square R we have to write, so it is a three-phase supply, means we have to multiply with 3. So 3 into I square R is the variable losses, right? And the second type we are having the constant losses. So here the constant losses are classified into two types. So in that, first one is iron losses. So here also the iron losses we can also call it as a core losses. The iron losses we can also call it as a core losses, right? So iron losses are nothing but the losses which are occurred at core of the stator and core of the rotor. We can call it as a iron losses. So these iron losses are includes hysteresis losses, and eddy current losses. These type of losses includes hysteresis losses and eddy current losses. So we can call it as a iron losses, right? And the next one is in constant losses, the second type is mechanical losses. So mechanical losses, so here mechanical losses are nothing but the losses which are occurred at shaft of the three-phase induction motor. Okay, the losses which are occurred at the shaft of the three-phase induction motor, and these type of losses are includes friction and windage losses. So here these type of losses are includes friction and windage losses. These are the different types of the losses in three-phase induction motor, right? So also we know about the efficiency. So what is meant by efficiency? So efficiency is nothing but it is the ratio of the output power and input power. It is the ratio of the output power and input power, and it is represented by neta, where neta is equal to output power, P output power divided by P input power. Suppose in terms of the percentage, so the percentage efficiency equal to output power divided by input power into multiply with 100. So percentage means we have to multiply with 100, where input power is equal to output power plus losses. What are the losses here? Variable losses plus constant losses, right? So here the output power we can also write like this: input power minus losses. So finally the efficiency, the percentage efficiency equal to output power divided by, so input power is output power plus losses, so substitute here. So here P output plus losses into 100, right? So here is the efficiency of the normally efficiency, the efficiency, percentage efficiency equal to output power divided by output power plus losses into 100. So we have to multiply with 100, right? So here in losses we are having the copper losses here. For example, if it is a full load copper losses, if it is a full load copper losses is the same as full load copper losses. Suppose for the half load, if it is a half load, how we can calculate the copper losses here? So copper losses at half load equal to, so here we have to do like this, so 1 by 2 whole square into copper losses, actual copper losses. Suppose if copper loss is 2000, so 2000 divided by 1 by 4, right? So we'll get the copper losses at half load. Suppose if it is 1 by third load, so the copper losses at 1 by third load is, so here also 1 by 3 whole square into copper losses. Or if it is a 1 by 4th load, so copper losses equal to 1 by 4 whole square into copper losses. Here is the calculation part of the copper losses. Remaining iron losses and mechanical losses, so these two are the, we have to take as the same here. But copper losses at half load, 1 by third load and 1 by 4th load, these are the difference here. Okay, here is the efficiency and losses in 3-phase induction motor. Okay, thank you one and all.